Good morning, students, and welcome to our second day of solving systems by elimination, where we have no common coefficients. And this is where we have to multiply one or both of the equations by some number in order to get those matching opposite coefficients so that we can eliminate one of the variables. So first, we're going to carefully respond. We have to our do now. It's a how are you doing do now, okay? So how are you doing? Checking in with ourselves today. Our objective is to continue to solve systems of equations using elimination where the variables have no common coefficients. Our essential question is, how can I use elimination to solve a system of equations? Again, we've got no common coefficients. Remember, coefficient is the 6 in 6x. It's the -7 in -7y. Our assignment, we will complete our do now in class notebook. We will watch the video. We have 7 assigned problems. They're a little more difficult than they were yesterday, but I know you can do it. We're going to answer our exit ticket in class notebook. And then remember to upload your completed assignment in Teams, which today is 1 page of work. We will complete our exit ticket, which asks us to review what we can do if we cannot multiply one equation in order to produce matching opposite coefficients. And that will be the distinction between yesterday and today. In many of today's problems, we're going to have to multiply both equations by some number in order to get those matching opposite coefficients. So for homework, I'd like you to do problems 7 through 12. And remember, full participation credit means our camera is on. Respond when your name is called at the beginning, middle, and end of the period. Ask for help when needed. Commit to working hard until you fully understand the concept, and write to me with your questions. Sorry about that. Let's get back to our PDF annotator. Now, map testing begins tomorrow. We will test for the first 2 hours. Then we will have 7 short periods. You know what? That is incorrect. That's been changed. We're going to have 4 normal length periods for the end of the day. Look for new calendar invites. So that has changed since I wrote that. We're going to have 4 normal periods. And what is going to happen is this correction I made down here. So if you are in period 2, I will see you on Thursday. If you are in period 5, I will see you on Friday. And I'll review this. By the time you see this video, I will have reviewed this, unless you're moving ahead. Okay, so here's our do now. How are you? Sometimes we just need to check in with ourselves. So in math today, we're going to rate your social life, are you having any fun, and your schoolwork. Give yourself a 1, 2, 3, 4, 5. 1 is really need to prove. Hey, 5, you're doing great. And then draw an arrow. Is this something that's improving or not? Which means you need to get yourself and get yourself going back in the right direction. So go ahead and rate yourself. If you want to talk about that, you can. You could write a sentence if you want. Now, for our exit ticket, we'll get back to that. Let's begin our lesson. So we started, we've been multiplying one or more equation by some number to produce matching opposite coefficients for one of the variables. So let's remind ourselves, we need matching opposite coefficients. Okay, now, so let's take a look at the first problem. We have 3x plus y equals 2, and 6x plus 2y equals 4. So if we multiply this first equation by 2, we can have matching, we'll be able to produce 2y for each equation, and then we can simply subtract the second equation from the first. So let's multiply this first one by 2, which will give us 6x plus 2y equals 4. And let's bring over our second equation, 6x plus 2y equals 4. And I think you see what's going to happen here if we put parentheses and subtract the second from the first. Everything cancels out, and we have 0 equals 0. What we've got here is an infinite number of solutions, meaning that these two equations are the same line. So let's take a look at that in Desmos. And here are those first two equations. And as always, I write them in the way they are presented in our book. I don't do any conversions. I'm not putting it in slope-intercept form. I like you to see that even if you do convert these equations to slope-intercept form, it's still the same line. So I'm entering these into Desmos as they are written in your homework page. So I'll turn off the second equation, and there you see the red line. And then and it looks like it has a y-intercept of 2. Right there, we see that. And let me turn on the second equation, the blue equation, and they are indeed the same line. So an infinite number of solutions for that problem. So the second problem, we have 3x plus 4y equals 6. And the second equation, 7x plus 8y equals 10. So it looks like I can multiply this first equation by 2, and I will have 8y in both equations. So let's go ahead and do that. And 3 times 2 is 6x. 4y times 2, that's a positive 8y, equals 6 times 2 is 12. Let's bring over our second equation, 7x plus 8y equals 10. And I'm going to change the color here. We're going to go ahead and subtract that second equation from the first equation. So 6 minus 7x is negative 1x. That 1 is an invisible 1. The 8y minus 8y eliminates the y terms, and 12 minus 10 equals 2. And of course, I divide both sides of this equation by negative 1, and x equals negative 2. Now, I will insert x into, I'm going to insert it into the first equation. So 3, instead of x, I have negative 2 plus 4y equals 6. That would be negative 6 plus 4y equals 6. I'll add 6 to both sides of the equation so I can isolate 4y. And then I'll divide both sides of the equation by 4 so that I get y equals 3. So my ordered pair is negative 2, 3. And let's take a look at the graph of these two equations. So here's 3x plus 4y equals 6, and 7x plus 8y equals 10. And we can see that the solution to this equation is negative 2, 3, exactly as we have found when we solved it using elimination. Okay, let's move on to number 8. Now, this is where we're going to do something a little bit new. We have 3x plus 3y equals 9, 5x plus 4y equals 10. So I cannot easily multiply one or the other of these equations to get a matching opposite coefficient. So I'm going to have to find a number that is the least common multiple of either 3 and 5 or 3 and 4, and then multiply each equation by that number so that I can get those matching coefficients. So I look at 3 and 5 and 3 and 4. I'm going to choose the 3 and the 4 because they're a little smaller. And I know that if I have a 3 and I have a 4, I know that the least common multiple of 3 and 4, let's look at the multiples of 3. 3, 6, 9, 12, 15. The multiples of 4, 4, 8, 12, 16. And I see that I have a least common multiple of 12. So I have 4 times 3 equals 12. And I have 3 times 4 equals 12. So my goal is going to be to get 12y and then just subtract the second equation from the first. So in order to do that, I will need to, let's use the green today, multiply the top equation by 4 and multiply the bottom equation by 3. And when I do that, this is what it looks like. So the top equation will become 12x plus 12y equals 36. And I multiply the bottom equation by 3, so that would be 15x plus 12y equals 30. Now I can go ahead and subtract the second equation from the first. 12 minus 15 is negative 3x. And 12 minus 12 eliminates the y's. 36 minus 30 is 6. And then I simply divide both sides by negative 3, and x equals negative 2. So see, this is what we did that was new. We had to multiply both equations to get that matching coefficient. Now I'm going to take the negative 2 and I'm going to substitute it for x in this first equation. So 3 times negative 2 plus 3y equals 9. 6 plus 3y, negative 6 equals 9. And then I will add 6 to both sides of each equation. And 3y equals 15. Divide both sides by 3. And y equals 5. And our ordered pair for this solution for this systems of equations is negative 2, 5. And let's look at the graph. So our first equation was 3x plus 3y equals 9, and 5x plus 4y equals 10. There we go. And let's go to a place where we can see that easily. And there is our solution, negative 2, 5. All right, let's look at number 9. We have 5x plus 9y equals negative 10, and 7x plus 10y equals negative 1. So I think I'm going to work with the x's, and the least common multiple of 5 and 7 will be 35. Because 5 times 7 is 35, and 7 times 5 is 35. So remember, I can always do this. I can say 5, 10, 15, 20, 25, 30, 35. And then the 7s, 7, 14, 21, 28, 35. And I see at 35 is the least common multiple. So I will multiply the first equation times 7, and I will multiply the second equation times 5. And I will be able to eliminate the x values. So when I multiply the first equation times 7, I have 35x plus 65y equals negative 70. And I'll multiply the second equation by 5, and I'll have 35x plus 50y equals negative 5. And now I will go ahead and subtract the second equation from the first. That eliminates my x values. 65 minus 63, excuse me, that should be a 63. I went 65. There we go. It's sort of nice working with the digital ink. It keeps your paper nice and neat. Okay, 63 minus 50 is 13y equals, now remember, this is where I see many, many, many mistakes. Subtracting a negative is adding a positive. Negative 70 plus 5 is negative 65. I just divide both sides by 13. And y equals negative 5. All right, I'm going to take that negative 5 and I'm going to insert it right here for y in the first equation. So 5x, I'm solving for x this time, plus 9, negative 5 is our substitution, equals negative 10. 5x, 9 times negative 5 is a negative 45, equals negative 10. We'll add 45 to each side so that we isolate the 5x, and then we'll eventually isolate x. 5x equals 35. Divide both sides by 5, and x equals 7. So our solution to this systems of equations is 7, negative 5. And of course, let's take a look at that graph, which is the greatest way to check your work and make sure you've done it right. So 5x plus 9y equals 10, negative 10. There it is. 7x plus 10y equals negative 1. And we're looking for a solution of 7, negative 5. And our solution is right there at the intersection of that blue and green graph. Beautiful graph. I love that graph. Oh, let's go on. We have a couple more problems to do. We're at number 10 now. So for number 10, we have 2x equals 4y plus, 4y plus 18. And negative 5x minus 6y equals 3. Students, I want you to notice something right away. The first equation is not in standard form. It's not in slope-intercept form. We have 2x isolated on the left. The second equation is in standard form. So the first thing I want to do with this is I want to write that first equation in standard form. So the first equation is 2x equals 4y plus 18. And I'm looking for ax plus by equals c. So all I really need to do is subtract 4y from each side. And I have 2x minus 4y equals 18. And that's our standard form, and that will help us to line up these two equations. Remember, we have to line them up so that the x's and y's line up. We cannot have an equal sign over to the left side and then over toward the right side of the equation on the second equation. We've got to line up the equal sign as well. So make sure you get both equations in the same form when you do this. So now that I've got this first equation in standard form, I'm going to rewrite that. 2x minus 4y equals 18. And the second equation, negative 5x minus 6y equals 3. Now, I still need to find those matching coefficients. So I think the easiest thing to eliminate is the y. We have 2 and 5, 4 and 6. I think that I'm going to go with a least common multiple of 12 between the 4 and the 6. So I'm going to multiply the first equation times 3 and the second equation times 2. So it takes a little preparation here before you can solve this problem. So 3 times 2x is 6x. 3 times negative 4y is negative 12y. And 3 times 18 is 54. 2 times negative 5x is negative 10x. 2 times negative 6y is negative 12y. 2 times 3 is 6. Now, be super careful with this. This is one of those problems where the negative signs can really get you. I have negative 12y, negative 12y. Well, if I add them up, I'm going to have negative 24y. What I want is 0y. So I'm going to subtract so that when I subtract the negative 12y, it will be like adding 12y, because subtracting a negative is the same as adding. And that's true of the negative 10x. So this will be 6x plus 10x, which is 16x, negative 12y plus 12y, which cancels our y's, and 54 minus 6 equals 48. And then I'll just divide both sides by 16, and x equals 3. Now I'm going to insert the 3, and I'm going to go ahead and use the very first equation as is, and I'm going to substitute for x right there. So 2 times 3 equals 4y plus 18. 6 equals 4y plus 18. I'll subtract 18 from each side. And negative 12 equals 4y. And I'll divide both sides by 4. And y equals negative 3. So my ordered pair, 3, negative 3. And let's look at the graph. So 2x equals 4y plus 18, negative 5x minus 6y equals 3, and my ordered pair, 3, negative 3, exactly as we found when we did our solution by hand. And number 11. So with number 11, again, I need to do some reordering. So I'm going to take the first equation is in standard form. I'll leave that as is. And the second equation, I'm going to add 6y to both sides. That will give me 3x plus 6y equals 12. So I've got both these equations in standard form. So I think what I will do is eliminate the y's. And I think I'm going to go with, I've got the 4y and I've got 6y. So I'm going to multiply the first equation by 3 and the second equation by 2. And then I'll solve for x. So let's do our multiplication first. 2x times 3 is 6x. 4y times 3 is 12y equals, let me neaten that up a little bit for you. 6 times 3 is 18. And then second equation, 2 times 3x is 6x. 2 times 6y is 12y. And 2 times 12 is 24. And let's subtract the second one from the first one. 6x minus 6x cancels the 6x's. 12y minus 12y cancels the y. So we've got 0 on the left side. 18 minus 24 is negative 6. What happened? This is not a true statement. This system of equations has no solution. Let's take a look at it. So we have 2x plus 4y equals 6, and 3x equals 12 minus 6. And indeed, look at that. We've got parallel lines, and there's no solution to that equation. In our final problem for the day, number 12, I have 7x plus 5y equals negative 13, and negative 2x equals 7y plus 26. So I need to put that second equation in standard form. I'm just going to subtract 7y from each side so that I have negative 2x minus 7y equals 26. So I'll write those here. My first equation, 7x plus 5y equals negative 13, and negative 2x minus 7y equals 26. And I think what I will do is multiply. I'm going to work with the x's. I'm going to multiply the first equation by 2 and the second equation by 7, so I get that common coefficient of 14. So 2 times 7x is 14x. 2 times positive 5y is 10y. And 2 times negative 13 is negative 26. 7 times negative 2x is negative 14x. 7 times negative 7y is negative 49y. And 7 times 26 is 182. Yes, I did use a calculator for that one. All right, so let's move on. We can just add these. We can just add, we don't need to put parentheses around this and subtract. We can just add the second equation to the first. 14 minus 14 eliminates those x's, and that is exactly what we wanted. 10 minus 49 is negative 39y equals negative 26 plus 182 is 156. And when we divide both sides by negative 39, you will find that indeed 156 is divisible by negative 39, and y will equal 4. Then I'm going to go ahead and take that 4, and I'm going to substitute it. I think I will use the second equation. It just looks easy. So I'm going to substitute this y in the second equation. So I have negative, in fact, let's move over into the margin here so we have a little extra room. Negative 2x equals 7, use parentheses for your substitution, times negative 4 plus 26. Negative 2x equals 28 plus 26. Negative 2x equals 28 plus negative 28. Excuse me, I forgot my negative. Negative 2x equals 7. Forgot my negative sign on the 4. Okay, here we go. Negative 28 plus 26 is negative 2. And negative 2 divided by negative 2. X equals 1. So we had a negative 4 here. Let me neaten that up. I want to make sure you see that. So 156 divided by negative 39 is a negative 4. And we put a negative 4 as our substitution. 7 times negative 4 is negative 28. Negative 28 plus 26 is negative 2. And then we finish it off and get x equals 1. So our ordered pair, 1 comma negative 4. And if I had not caught that mistake now, I would have caught that mistake when I go to check my work by graphing it on Desmos. So 7x plus 5y equals negative 13 is our green line. Negative 2x equals 7y plus 26 is our purple line. And the solution to that equation is 1, negative 4. And again, if I had not caught my mistake, I would have found my mistake on Desmos, which would have meant I would have gone back and then I would have found my mistake and corrected my work, which is exactly what you should be doing, especially when you are taking a test. So Desmos is a great way to check your homework without asking for extra help. So what should I do if I cannot multiply one equation in order to produce matching opposite coefficients? So what you should do is find a least common multiple. Ooh, that's pretty bright. For either variable, either coefficient. And multiply by that number. So you're going to multiply both equations by some number to produce matching coefficients. Okay, let's review this again. So you need to find a least common multiple for either coefficient. So you can either work with your variable x or your variable y. You get to decide that. You will, if you work correctly, you will get the correct answer, whether you work with the x value or whether you work with the y value. It won't matter, students. But find a least common multiple for either coefficient, multiply both equations by some number to produce that least common multiple, which will be your matching coefficient, and then continue to solve as usual. I know these take a bit of practice, but you'll do it. You've got a few problems for homework, so keep working hard, and as you do so, you know that you'll be great.